Part 3. Peeling back the layers.
This is presented to you by Education 4708. Just proceed to view the full content.
An introduction to Bitcoin mining. Bitcoin mining is a core part of Bitcoin. Miners create new Bitcoins and validate transactions. This makes the Bitcoin network trustworthy. Without mining, Bitcoin could not function. It is a decentralized security mechanism. Think of it like digital gold mining. Instead of digging earth, miners use computers. They solve very hard mathematical puzzles. This effort secures the entire network. It ensures all transactions are legitimate. So what is Bitcoin mining fundamentally? It is a competitive, decentralized process. It validates transactions into consistent blocks. It adds these blocks to the blockchain. The blockchain is a public ledger. Miners around the world do this job. Shouting into the digital void, broadcasting Bitcoin transactions. A Bitcoin transaction starts with a user. Imagine you want to send Bitcoin. You use your Bitcoin wallet to do this. The wallet software creates a transaction message. This message contains all the details. It says who is sending the Bitcoin. It says who is receiving the Bitcoin, and it states the amount to be sent. Before sending, your wallet signs the transaction digitally using your private key. This signature proves you own the Bitcoin and ensures the transaction is not altered. Once signed, the transaction is broadcast to a few Bitcoin nodes. These nodes are computers running Bitcoin software. They are connected to the Bitcoin network. Think of it like shouting news in a crowd. The transaction spreads like a ripple. The goal is for the transaction to reach miners. The waiting room. Understanding the mempool. After a transaction is broadcast, it enters a waiting area called the mempool. Mempool is short for memory pool. It is a holding space on Bitcoin nodes. Each node on the network keeps its own mempool. It stores unconfirmed transactions temporarily. The mempool is like a busy waiting room. Many transactions arrive continuously from users. They all wait to be processed by miners. Miners usually choose transactions that pay higher fees. When you send a transaction, you include a fee. This fee is an incentive for miners. Transactions with higher fees are more attractive. They often get picked from the mempool faster. The size of the mempool can change a lot. Monitoring the mempool gives insights into network traffic. Section 4. The digital sieve. How miners select transactions and form blocks. Miners play a crucial role in transaction processing. They look at the transactions in their mempool. Their goal is to create a new block. This block will be added to the blockchain. Miners prioritize transactions based on profit. Each transaction includes a small fee. Miners collect these fees for transactions they include. They typically select transactions with higher fees. Besides user transactions, miners add one more. It is called the Coinbase transaction. The miner creates this transaction themselves. It includes the block reward and all the fees from other included transactions. Once transactions are selected, a block is formed. Section 5. The Great Digital Race Proof of Work explained. After creating a candidate block, the real work begins. This is the mining part of Bitcoin mining. It involves solving a difficult computational puzzle. This system is called Proof of Work, POW. POW is Bitcoin's consensus algorithm. It ensures that adding blocks is hard. Many miners compete to solve this puzzle. The puzzle involves using the SHA-256 hashing algorithm. Miners take the header of their candidate block. They add a random number called a nonce. Then, they hash this data repeatedly. The goal is to find a hash value below a certain target. The target is set by the network's difficulty. The first miner to find a valid hash wins. This self-regulating feature is key to Bitcoin's stability. Section 6. The network stamp of approval, block validation. When a miner successfully finds a valid proof of work, their candidate block becomes a valid new block. They have won the right to add it. The first thing they do is broadcast it. They send their newly minted block to the network. This is similar to broadcasting transactions. The block quickly spreads to all connected nodes. Other nodes on the Bitcoin network receive this block. They do not just accept it blindly. Each node independently validates the block. This is a very important security step. They check many things to ensure its legitimacy. This verification ensures all rules are followed. It prevents invalid blocks from being added. What do nodes check during validation? First, they check the proof of work. Is the hash of the block header correct? Does it meet the current difficulty target? Then, they check all transactions in the block. If the new block passes all these checks, the node considers it valid. Section 7. Coins for a cause, miner rewards, and network security. Why do miners perform all this hard work? The answer lies in the incentives provided. Miners receive two types of rewards. These rewards make mining profitable for them. The first reward is newly created bitcoins. This is called the block subsidy. It is part of the Coinbase transaction. This is how new bitcoins enter circulation. The second type of reward is transaction fees. As mentioned, users attach fees to transactions. Miners collect all fees from transactions. The block subsidy halves approximately every 4 years. This event is known as the halving. It reduces the rate of new Bitcoin creation. Eventually, the block subsidy will become zero. This design ensures mining remains viable. Comments down here if really it helps your journey on digital currency and online money making. Don't forget to like, share, and subscribe.